Hi everyone, today in Integrated Math 2 we're going to go over Chapter 2, Lesson 3. Here are the objectives. Make sure you write them down in your notes. Alright, so let's go over some of the key concepts. Vertical translations. So, vertical means up and down. Don't forget about that. Think about like when you're standing up and then you sit back down. The graph of f of x is equal to x squared plus k. That's where it's important. The k tells us if we're going to go up or down on the graph. Vertically, if k is greater than 0, then it will go up. If k is less than 0, then it will go down. Alright, now horizontal translations. So this one is when g of x is equal to x minus h squared, the graph is translated horizontally. If h is greater than 0, then it's translated to the right. If h is less than 0, it is translated to the left, as shown here. Dilations. So dilations are when we have things like g of x is equal to ax squared. And notice the a will be something other than 1. There's a 1 right here. So our dilations are going to tell us if our graph is getting like really skinny or if it's expanding. So as you can see here, if the absolute value of a is greater than 1, then it's stretched vertically. So it's making it smaller because it's getting taller and it's being stretched out. If 0 is less than the absolute value of a less than 1, then it is being compressed vertically, which means it's being expanded. It's being made bigger from left to right, as you can see in the picture. Alright, so reflections, think about like a mirror. Here would be like the mirror. It's being flipped. You can see it. And this is really going to be when you see that negative with the f of x. That's how you know that we have a reflection. So this one is f of x, and we have negative f of x here. And make sure, if you haven't done so already, make sure you copy down the translations of quadratic functions. And as you can see here, we can have every single one of these in a problem. We can have an a, we can have an h, and we can also have a k. So just keep that in mind. It can move left and right, up and down, and it can also dilate and reflect. It's not limited to one function. But let's go ahead and try example 3. We want to describe the graph of f of x, which is equal to x squared minus 2. And we want to say how it's related to the graph of f of x, which is equal to x squared. Well, for this one, we know that, so I'm going to go ahead and rewrite it. F of x is equal to x squared minus 2. This is our normal function here. But this negative 2 is actually a c. And the c represents a translation. The c represents a translation, but the question is, does it go up or down? Well, since c is actually equal to negative 2, we know that the graph is translated 2 units down. I'm going to say translation 2 units down. It's a matter of just knowing and seeing what we have for our functions here to be able to determine what we need to do. So now let's go ahead and look at example 4, which is a little different. We want to write an equation for the function shown in the graph. So first of all, we see that the graph opens up. So we know the leading coefficient must be positive. So I'm going to start with f of x is equal to x squared. Because I do know that has to be x squared, that's our parent function. It's a parabola. It makes a u. And we know it has to be positive, like we said, because it opens up. So good so far. I don't need a negative. If it was opening down like this, then I would need to have a negative here. But for this one, not the case. And then, as we can see, the parabola has not been moved up or down, so that's good. So we also know that C is at 0. But as we can see here, though, we can see the graph has been stretched vertically. So as you can see, it's a little skinnier than one of the normal parabolas. Because of that, I know that we have f of x, which is equal to ax squared. And we're just going to say that a must be greater than 1 because it is being stretched. So let's just go ahead and give an example of one. So f of x is equal to a number greater than 1. So let's say 2x squared. That's it.